All right, welcome to 6.5a. Here we're just reminding you of the basic graphs of sine, cosine, cosecant, and secant. The goal of all of this is to have you be able to graph any trig function. And so even with movement that's going on, just like you did back in your trigonometry class. And so we're just reminding you what they look like. Sine starts at 0 and goes to 2 pi. They all do these little wave things. Cosine at 0 is 1, and so a full period he's showing it going from negative pi over 2 to 3 pi over 2, and it looks like that. Its height is 1, right? So what we're doing is plotting the angles along with their cosine outputs, and so we'll get these memorized. As you remember, cosecant is the flip of sine, and so what it does is, let me come down here, it goes off of your sine graph. Remember, your sine graph from above looks like this, and it creates these humps right off the top of it. And then the secant graph, you would naturally draw your cosine graph, right, that starts at 1. I always start at 0, but at 0 it's 1, and it falls and comes here. And so you can see that secant and cosecant have these asymptotes. And the reason why they have the asymptotes is because that's where they're undefined. It's because that's where, if I focus on cosecant here for a moment, if you look at sine of pi, it's flat out 0. And so sine of pi is 0, so cosecant's the flip of that, so that's 1 over 0. And that's going to be undefined, so it's shooting off to infinity there. Tangent. Tangent looks like this. It's got vertical asymptotes at minus pi over 2 and pi over 2. Has a period of pi, which kind of makes sense with being able to, well, it was definitely reinforced with being able to get by with just a single 1 pi addition when we had to list out all of those. And then cotangent is, so tangent's going through 0. So how I remember what tangent looks like is tangent theta is sine theta over cosine theta. So it's going to be 0 whenever sine's 0. So sine is 0. Sine of 0 is 0. So it's going right through there. And then it goes up from there and down. Because I know in the first quadrant, where we have angles between 0 and pi over 2, we are positive. And in the fourth quadrant, which is where we are over here, we have angles that are, our tangents are negative in that case. And so I just know it goes up that way. Same with you. Hopefully the discussion of quadrants made sense to you, because you're not looking at the true quadrants here. You're looking at a number line. And so he's using this just to remind you of what these basic graphs look like. So this is where we'll come back to all these parent graphs. Cotangent then is cosine theta over sine theta. So I'm trying to think, well, when is cosine theta 0? And cosine theta is 0 at pi over 2. Well, that's exactly where cotangent theta is going to be 0. So remember, this right here represents first quadrant angles because they're between 0 and pi over 2. So cotangent is going to be positive there. But in the second quadrant, between pi over 2 and pi, it's going to be negative. So I'll always have an anchor to remember that it's falling as you look at it from left to right. As you look at tangent, it's increasing from left to right. And I'm just trying to point out the ways where you'll know where those zeros are, because it may have been a long time since you've graphed these guys. But these are the basic ones that we're going to be using in the subsequent sections in order to get different pictures.